Berlin's confidence in 1939 wasn't just propaganda. It was based on cold industrial mathematics that every major power accepted as fact. The German High Command had studied Britain's aircraft manufacturing capacity with the same precision they applied to everything else. And their intelligence reports painted a straightforward picture. British factories employed roughly 350,000 skilled workers producing military aircraft, and German analysts knew exactly what would happen when war came. Conscription would gut those factories. The Luftwaffe's Economic Warfare Division estimated that within 18 months of war's outbreak, Britain would lose 70% of its aircraft production capacity, not from bombing raids, but from simple arithmetic. The logic seemed unassailable. Aircraft manufacturing in the 1930s demanded years of apprenticeship. A single Spitfire required over 20,000 individual parts, each machine to tolerances of thousandth of an inch. Wing assemblies needed perfectly aligned rivet holes drilled through aluminum sheets, whilst maintaining aerodynamic curves. Engine installations demanded workers who understood the relationship between torque specifications and metal fatigue. Electrical systems required fitters who could trace hundreds of wire connections through cramped fuselages. This wasn't factory work that any warm body could perform after a few days' training. German intelligence knew that Britain's skilled tradesmen, the tool makers, sheet metal workers, precision fitters, and instrument specialists, represented an irreplaceable resource built up over decades of peacetime industrial development. When Britain declared war on the 3rd of September 1939, the German calculation seemed to be proving itself immediately. The Air Ministry faced an impossible equation. Fighter Command needed 1,000 new aircraft monthly just to maintain current squadron strength. But that figure assumed no losses. Once combat started, attrition rates would demand far more. Yet the very act of building a military force would destroy the capacity to build military equipment. Every skilled man who volunteered for the RAF, the Army, or the Royal Navy was a skilled man, no longer tightening bolts on a Hurricane's engine mount or calibrating gun synchronization mechanisms on a Blenheim's nose. Reich Minister Albert Schar's office circulated internal memos in early 1940 that treated British industrial collapse as inevitable. Their projections showed that by mid-1941, British monthly aircraft production would fall below 400 units. Less than half what Germany could produce, and nowhere near what Britain would need to replace combat losses. The Luftwaffe could afford to trade aircraft at even odds during the planned invasion, because German factories would maintain output whilst British production withered. Some German planners even suggested that bombing British aircraft factories was unnecessary. Why waste ordnance on targets that would soon stand empty anyway? The German assessment rested on an assumption so fundamental that it appeared in no written report because it needed no stating. Industrial production at this level of complexity required men, not just any men, but men with years of training, men with the physical strength for heavy metal work, men with the temperament for precision engineering. This wasn't bias or ideology speaking. It was the observed reality of every industrialized nation. In 1939, Germany's own armaments factories employed virtually no women in skilled positions. American aircraft plants were the same. Soviet factories used women primarily for basic assembly work under male supervision. The international manufacturing consensus held that modern warfare demanded industrial capacity that only male workers could provide. Britain's factories employed some women before the war, of course, but they worked in finishing, painting, fabric work, or basic assembly roles that supported but didn't replace skilled trades. The German High Command saw no reason to doubt that Britain would follow the same industrial logic that governed warfare since the Industrial Revolution. Skilled workers couldn't be mass-produced. Apprenticeships couldn't be compressed. Manufacturing precision couldn't be maintained by untrained labor. Britain would have to choose between an army and an air force, between defending Egypt and defending Kent, between maintaining production and manning the guns. They were about to discover how catastrophically wrong expertise could be. The National Service Act became law on the 3rd of September 1939, the same day war was declared. Within 6 months, the theoretical problem German intelligence had identified became Britain's lived nightmare. Young men received their call-up papers in waves, and factory floors that had buzzed with lathes and rivet guns began echoing with absence. Supermarines. Southampton Works lost 40% of its skilled fitters by March 1940. Vickers Armstrongs and W. Bridge watched 300 toolmakers leave for basic training in a single month. Hawker's Langley facility saw its experienced sheet metal workers disappear into khaki uniforms. Faster than production managers could reorganize work schedules, the numbers told a brutal story. In September 1939, Britain's aircraft industry employed roughly 350,000 workers. By December 1940, that figure had dropped to 210,000, and those remaining skewed older, less experienced, or held reserved occupations that kept them from frontline service. The Metropolitan Vicers Works in Manchester, which produced electrical components for bombers, lost 62% of its pre-war workforce by spring 1941. De Havilland's Hatfield plant, responsible for producing the Mosquito prototype, operated with just over half its September 1939 staffing levels throughout 1940. But conscription wasn't the only drain. The factory workers who remained faced their own impossible choices. Skilled tradesmen who'd avoided call-up through reserved occupation status found themselves pressured to volunteer. The social weight of seeing neighbors in uniform, of reading casualty lists from Dunkirk, of watching newsreels showing Spitfire pilots climbing into cockpits. It made staying at a workbench feel like cowardice, regardless of how essential the work was. Between January and June 1940, Rolls-Royce's Merlin engine plants Inderby and Crewe lost over 800 workers to voluntary enlistment, despite those men holding official exemptions. Production quotas, meanwhile, moved in the opposite direction. In May 1940, with France collapsing and the Luftwaffe preparing for the battle ahead, the Air Ministry demanded 2,300 aircraft monthly by year's end. This wasn't ambitious. It was arithmetically impossible with the workforce available. A single Wellington bomber required 28,000 rivets, each one driven by hand. A Lancaster's wing assembly demanded 14-hour shifts of continuous precision work. The Merlin engines powering Hurricanes and Spitfires needed 70 hours of skilled machining per unit just for the crankshaft. Factory managers found themselves supervising production lines that looked like something from a fever dream. At Castle Brummage, the massive Shadow factory built to produce Spitfires at unprecedented scale. The facility opened in July 1940 with capacity for 1,000 workers, but only 320 actually present. Lord Beaverbrook, newly appointed Minister of Aircraft Production, visited the plant and found assembly jigs standing empty, tool cribs locked because there weren't enough workers to justify keeping them staffed, and partially completed airframes sitting idle because the few remaining fitters couldn't handle multiple production stages simultaneously. By spring 1941, the mathematics had become absurd. Britain needed 600 new fighters monthly just to replace Battle of Britain losses, plus bombers for the strategic campaign, plus training aircraft for the expanding Commonwealth Air Training Plan, plus maritime patrol aircraft for convoy protection, plus transport aircraft for supply operations. The total requirement exceeded 5,000 aircraft monthly. The available skilled workforce could perhaps manage 1,500 if they worked themselves to exhaustion. German intelligence officers reading intercepted production reports must have felt vindicated. The British industrial base was collapsing exactly as predicted, just from the internal logic of total war. What they didn't know was that Britain had already made a decision that would invalidate every assumption those predictions rested upon. Ernest Bevenon, Minister of Labor and National Service, stood before Parliament on the 18th of December 1940 with a proposal that would have seemed unthinkable 18 months earlier. Britain would conscript women not for auxiliary services or nursing or clerical work, but for the factory floor, for aircraft manufacturing, for the precise, demanding, supposedly male work of building Spitfires and Lancasters. The announcement landed like a bomb in a society still operating under Victorian assumptions about women's capabilities. Bevan wasn't proposing this because he was progressive or visionary. He was proposing it because Britain had run out of alternatives. The Ministry of Labor established the framework with remarkable speed. The registration for employment order issued on the 19th of March 1941 required all women aged 18 to 60 to register at local employment exchanges. This wasn't a voluntary scheme or a recruitment drive. It was compulsory national service. Women would be directed into essential. War work and aircraft manufacturing topped the list. The ministry projected they needed 700,000 women in engineering and aircraft production. Within 12 months, the existing female workforce in these industries stood at roughly 90,000, mostly in unskilled roles. Whitehall was proposing to increase that eightfold in a year. The recruitment campaign that followed made D-Day planning look simple. The Ministry of Labor divided the country into regions, each with quotas for female industrial workers. Employment exchanges interviewed registered women to assess their suitability for different war work. Those deemed appropriate for aircraft manufacturing received summons to training centers, not invitations, summons. Housewives who hadn't worked outside their homes since marriage found themselves informed they'd be operating milling machines in 6 weeks. Shop assistants from Marks and Spencer learned they'd be fitting hydraulic systems into bomber tails. Hairdressers, seamstresses, teachers on summer break, the ministry cast a net so wide it captured nearly every woman without dependent children under 5. The target demographics revealed the scale of social transformation involved. The ministry specifically sought women between 20 and 40, peak childbearing years in 1940s Britain. They wanted housewives whose husbands were now overseas, women who understood discipline and routine. They recruited from shops because retail workers knew how to handle customers under pressure and follow exacting standards. They pulled from textile mills because fabric workers understood machinery and possessed manual dexterity. The ministry even recruited from domestic service, reasoning that women who'd spent years managing aristocratic households understood precision and attention to detail. Administrative challenges emerged immediately. Training centers needed establishing across the country, which meant requisitioning buildings, installing equipment, and finding instructors qualified to teach aircraft manufacturing to complete novices. The government training centers in places like Sheffield, Coventry, Birmingham, and Glasgow expanded from teaching unemployed, men during the Depression, to processing thousands of women monthly through accelerated engineering courses. Each center needed lathes, drill presses, rivet guns, sheet metal brakes, electrical testing equipment, and mock-up aircraft sections for practice assembly. Transport became its own crisis. Factories operated 3 shifts to maximize production, which meant women working nights in industrial areas far from their homes. The ministry organized buses, negotiated with railways for special workers' services, and in some cases arranged hostel accommodation near major plants. Women from Cornwall found themselves billeted in Coventry. Scottish women took lodgings in Southampton. The logistics of moving hundreds of thousands of women across Britain whilst also managing military transport needs tested the country's infrastructure to breaking point. And through all of this, one question dominated every discussion in Parliament, in newspapers, in factory cantons, and in homes across Britain. Could this possibly work? Could women who'd never held a wrench-built aircraft that would keep pilots alive? The answer would determine whether Britain could fight at all. The resistance wasn't subtle. Trade union representatives from the Amalgamated Engineering Union met with Ministry of Labor officials in January 1941 and stated their position bluntly. Women lacked the physical strength and technical aptitude for skilled engineering work. This wasn't coming from reactionary dinosaurs. These were the same unions that had fought for workers' rights, that had organized strikes for better conditions, that represented the very men now being asked to train female replacements. Their objections weren't rooted in malice, but in generations of workshop experience. That said, precision metalwork required male strength and stamina. Factory foremen echoed these concerns with technical specificity. A flight of rivets along a Lancaster's fuselage required sustained pressure on a pneumatic gun that vibrated violently, enough to numb hands through thick gloves. Women's supposedly smaller hands would struggle to maintain the grip pressure needed for proper rivet compression. Foreman argued wing spare assembly involved maneuvering aluminum sections weighing upwards of 40 pounds into precise alignment while simultaneously operating hydraulic clamps. Sheet metal work demanded the arm strength to operate foot pedals heres that could slice through quarter-inch aluminum plate. These weren't arbitrary barriers. They were the physical realities that every apprentice faced during years of training. The technical concerns went beyond brute strength. Aircraft electrical systems in 1941 contained hundreds of individual wire connections, each one requiring stripping, crimping, and soldering to specifications measured in millimeters. One reversed polarity in a gun synchronization system could result in a pilot shooting off his own propeller. One loose connection in a fuel pump circuit could leave a bomber with dead engines over the North Sea. Foreman questioned whether women possess the spatial reasoning to visualize complex, three-dimensional wiring runs through airframe structures or the mechanical intuition to troubleshoot hydraulic systems, exhibiting intermittent failures. Even some pilots voiced doubts, though usually in private. Squadron leader Douglas Bader, already a legend by 1941, reportedly told a gathering at Duxford that he trusted his life to Spitfires built by men who understood flying, who'd perhaps flown themselves, who knew that a fighter pilot's life hung on every bolt talk to proper specification. How could a housewife from Tunbridge Wells understand what it meant when a Merlin engine coughed at 12,000 DFT? The comment reflected an attitude that pervaded RAF messes. Respect for the women joining the war effort, certainly, but skepticism about whether they could match the standards male craftsmen had established. Medical professionals added their own concerns to the chorus. The factory environment posed risks that doctors argued women's physiology made them uniquely vulnerable to. Extended exposure to industrial solvents used in aircraft manufacture could affect reproductive health. A genuine concern, though it conveniently ignored that those same solvents affected male-fertility too. The noise levels in aircraft factories regularly exceeded 100 dB, which some physicians claimed women's supposedly more sensitive hearing couldn't tolerate. The shift work required for round-the-clock production would disrupt women's natural rhythms more severely than men's, or so the medical establishment suggested. Social commentators questioned the broader implications. Magazine articles wondered whether women doing men's work would become coarsened, unwomanly, unable to return to domestic life after the war. Churches worried about moral implications of women working night shifts in mixed gender environments. Conservative MPs gave speeches about the breakdown of traditional family structures if mothers spent their days riveting bomber fuselages instead of raising children. Yet beneath all these objections ran a current of simple disbelief. The task seemed too large, too complex, too demanding. Britain was proposing to take women with no engineering background whatsoever and trust them to build some of the most sophisticated machines humanity had ever created. Every precedent suggested this would fail catastrophically. The government training centers didn't waste time on theory. When Mary Churchill, no relation to the Prime Minister, arrived at the Sheffield Center in April 1941, she'd been a secretary at a law firm the previous week. Her first morning began not with lectures about metallurgy or engineering principles, but with a rivet gun placed in her hands and an instructor showing her how to hold it. The training philosophy was brutally simple. Learn by doing and do it until muscle memory replaced conscious thought. The 6-week courses that began rolling out across Britain in early 1941 weren't traditional apprenticeships compressed. They were entirely new approaches to skills transfer designed around wartime urgency. Week 1 focused exclusively on tool familiarity. Trainees spent 8-hour days handling drill presses, operating lathes, using micrometers and calipers, feeling the difference between properly torqued bolts and loose ones. Instructors, often retired craftsmen or workers with medical exemptions, demonstrated techniques once, then watched, whilst women repeated the action 50 times, or 100 times until their hands moved correctly without thinking. The centers discovered that women's supposedly delicate hands actually proved advantageous for certain operations. Smaller fingers could reach into cramped spaces in cockpit assemblies where larger male hands struggled. The dexterity developed through years of sewing, knitting, or detailed housework transferred directly to precision wire work. Week 2 introduced actual aircraft components. The training centers had obtained damaged aircraft sections from combat or training accidents. Spitfire wing panels riddled with bullet holes. Hurricane fuselage frames bent from hard landings. Wellington tail sections with structural damage. Trainees learned to remove damaged rivets and install replacements working on real aluminum rather than practice sheets. They stripped Andrey-assembled Merlin engine components, learning to recognize proper bearing surfaces versus worn ones through touch alone. The tangible connection to actual aircraft made the stakes visceral. These weren't abstract exercises. Every rivet they learned to install correctly was arrivé that would keep a pilot alive. Weeks 3 and 4 focused on specialization. Women showing aptitude for electrical work moved to wiring harness assembly, learning to read circuit diagrams and trace faults through complex systems. Those with steady hands under pressure specialized in instrument installation, where a single millimeter's misalignment could render alimiters or airspeed indicators dangerously inaccurate. Others moved to hydraulic systems, fabric work, or engine fitting based on demonstrated strengths rather than preconceived notions about suitable women's work. The training incorporated innovations that traditional apprenticeships had never considered. Visual aids replaced lengthy verbal explanations. Color-coded wiring diagrams showed connections more clearly than technical descriptions. Assembly jigs were redesigned to require technique rather than brute strength, using mechanical advantage and proper positioning instead of raw force. Instructors discovered that women asked different questions than male apprentices, often identifying unclear procedures or ambiguous specifications that had been passed down through informal workshop culture for years. These questions led to written documentation that improved training efficiency for everyone. Week 5 meant production simulation under pressure. Trainees worked against stopwatches, assembling components to actual factory quotas. They learned to spot fatigue in themselves and correct errors before they became problems. Night shift simulation trained them to maintain quality whilst exhausted. The failure rate was roughly 20%. Women who couldn't meet the speed or precision standards returned to other war work, but the 80% who succeeded emerged certified for specific aircraft manufacturing roles after 42 days of training. By the end of 1941, government training centers were processing over 12,000 women monthly with pass rates that shocked even ministry officials who designed the program. The training wasn't producing master craftsmen, but it was producing competent specialists who could perform specific operations to aircraft manufacturing standards, and Britain needed hundreds of thousands of them. The first Spitfire, assembled entirely by a predominantly female crew, rolled out of Castle Bromwich on the 14th of July, 1941. Flight Lieutenant Hugh Dundas climbed into the cockpit that afternoon, ran through pre-flight checks, and took off without incident. He later wrote that he'd been watching for any sign of assembly problems, any vibration or control flutter that might indicate rushed work or improper fitting. The aircraft performed flawlessly. Within 6 months, Castle Bromwich employed over 10,000 women, producing 500 Spitfires monthly, more than the entire British aircraft industry had managed in any month before the war. The production figures that began emerging by mid-1942 made German intelligence reports look like fantasy. Supermarines dispersed production facilities across southern England, staffed predominantly by women, produced Bat 348. Spitfires between 1940 and 1945. Of Rose, Manchester, and Chatton, works where women constituted 75% of the workforce by 1943, assembled 377. Lancaster bombers. De Havilland's Hatfield and Leavesden plants built 7,781 Mosquito aircraft with work teams that shifted from male-dominated to female-dominated between 1941 and 1943. The sheer variety of aircraft that women assembled demonstrated the breadth of their capabilities. At Hawker's Langley facility, women built 90-100 Hurricanes, while simultaneously handling production of the Typhoon ground attack fighter, a temperamental aircraft that demanded exceptional precision in engine installation to prevent the cooling system failures that plagued early models. Vickers Armstrong's facilities saw women assembling Wellington bombers, with their geodetic construction requiring over 40,000 individual component installations per airframe, a design so complex that even pre-war male workers had found it challenging. Short Brothers Rochester and Belfast facilities producing Stirling and Sunderland aircraft presented particular challenges. The Stirling bomber stood over 6 meters tall with a wingspan exceeding 30 Ballard men. Assembly required working at height on scaffolding, maneuvering massive wing sections into position, and installing 4 Bristol Hercules engines that weighed over 800 kilos each. Yet by 1943, women formed the majority of workers on Stirling production lines. The Sunderland flying boats demanded different expertise entirely. Sealing whole seams to prevent water ingress, installing marine equipment, and ensuring structural integrity for water landings. Women mastered these specialized requirements just as they had fighter assembly. Bristol Aeroplane Company's Filton Works saw women building Bow fighters and Blenheim mimes while simultaneously handling subcontract work for other manufacturers. Handley Pages, Cricklewood and Radlett facilities produced 763 Halifax bombers with predominantly female assembly teams by 1944, even smaller manufacturers, like Miles Aircraft producing trainers, and light aircraft shifted to majority female workforces, without production declines. The numbers accumulated relentlessly. 41, 20,094 aircraft. 1942, 3,672 aircraft. 1943, 26,263 aircraft. The peak came in 1944 with 26,461 aircraft, more than Germany produced that year. Despite their larger industrial base and longer preparation time, Britain's female workforce wasn't just replacing departed men. They were exceeding what those men had accomplished. By war's end in 1945, British factories had produced over 120,000 military aircraft during the conflict. Women had directly assembled at least 75% of them and contributed to their remaining 25% through component manufacturer and subassembly work. German intelligence's prediction of a 70% production decline had been inverted. Production had increased 700% instead. Every assumption about industrial capability, about workforce requirements, about the supposed necessity of male labor for complex manufacturing had been systematically disproven by women with rivet guns and wiring diagrams. Production numbers told only half the story. What the statistics couldn't capture was how women weren't merely replicating the work methods men had established. They were improving them. At Vickers Armstrong's Weybridge facility in September 1942, a production bottleneck had stalled Wellington bomber output for 3 weeks. The geodetic lattice structure that gave the Wellington its legendary durability also made final fuselage assembly incredibly complex. Sections had tow line within 2 millimeters across the entire airframe length, and the traditional method involved 4 experienced fitters working simultaneously with measuring rods and adjustment tools. The process took 14 hours per aircraft and required workers who trained together for months to develop coordination. Dorothy Russell, a former primary school teacher from Guildford, watched the process for 2 days and suggested something the engineering staff had never considered. Instead of 4 workers trying to coordinate adjustments verbally across 10 meters of airframe, why not use visual reference points? Shep proposed painting alignment marks on the internal structure at critical junctures, allowing each worker to independently verify their section's position without constant communication. The engineering team initially dismissed the idea as oversimplification, but the production manager authorized atrial. Assembly time dropped to 9 hours. By November, every Wellington production facility in Britain had adopted the technique. Similar innovations emerged across the industry, often from women whose lack of traditional training meant they hadn't learned to accept inefficiency as inevitable. At Castle Bromwich, assembly line workers noticed that Spitfire wing panels occasionally arrived from subcontractors with rivet holes slightly misaligned, requiring time-consuming corrections during final assembly. Male supervisors had treated this as normal manufacturing variance. A quality control team of women suggested implementing go-no-go gauges at the subcontractor level. Simple templates that would immediately identify alignment problems before components reached final assembly. Rejection rates at receiving inspection jumped initially, but within 6 weeks, subcontractors had corrected their jigs and misalignment issues virtually disappeared. Assembly time per aircraft dropped by 3 hours. The electrical systems in Lancaster. Bombers presented persistent problems throughout. 1942, intermittent failures in navigation. Lighting circuits plagued squadron operations with aircraft, returning from missions reporting lights that flickered or failed entirely. Male engineers at Avro's Chatterton Works had spent months checking wire specifications, connector quality, and circuit design without identifying the root cause. In January 1943, an electrical fitter named Margaret Dobson noticed that problems occurred more frequently on aircraft assembled during night shifts. She hypothesized that tired workers were accidentally pinching wires between airframe sections during assembly, creating damage that didn't manifest until vibration and temperature cycling during flight caused insulation to fail. Her solution was elegantly simple. root wiring harnesses through protective rubber grommets at every bulkhead penetration, adding perhaps 15 minutes to assembly time, but eliminating pinch points entirely. The modification became standard on all subsequent Lancaster production and was retrofitted to existing aircraft during routine maintenance. Night lighting failures dropped by 92% within 3 months. At Handley Page's facilities, women working on Halifax bomber hydraulic systems identified a design flaw that male engineers had worked around rather than solved. The hydraulic lines running to the rear turret passed close to exhaust stacks, causing fluid temperatures to rise during extended flights and reducing system pressure. The official solution involved instructing gunners to operate turrets gently to avoid hydraulic strain. A team of women suggested simply rerouting the lines an additional 10 centimeters from the exhaust path using brackets that added negligible weight. Engineering staff protested this would require design modifications, but production managers overruled them. The fix cost virtually nothing and eliminated turret hydraulic problems that had been accepted as unavoidable for 2 years. The Luftwaffe's strategic planning for Britain had always relied on mathematics rather than luck. Their operations research teams had calculated that if they could destroy British aircraft faster than factories replaced them, fighter command would wither regardless of pilot courage or tactical brilliance. The strategy appeared sound in July 1940 when the Battle of Britain began. Shoot down 6 Spitfires today and tomorrow only 4 replacements arrive. Continue that equation for 3 months and the RAF ceases to exist as an effective force. Hermann Göring confidently predicted fighter command's collapse by October 1940. The first cracks in German confidence appeared in September 1940. Luftwaffe. Intelligence estimated they destroyed over 1,000 RAF fighters between July and early September. Fighter command should have been operating with skeleton squadrons, yet every raid encountered full-strength opposition. Bomber crews reported the same phenomenon. The Spitfires and Hurricanes they were supposedly destroying kept appearing in undiminished numbers. German pilots began privately questioning whether their victory claims were accurate or whether British factories possessed capabilities that intelligence had missed. The actual figures revealed the truth. During the critical phase of the Battle of Britain between August and October 1940, Fighter Command lost 9-115 aircraft to all causes, combat, accidents, and training losses combined. British factories delivered 1,581 replacement fighters during the same period, a net gain of 666 aircraft. The Luftwaffe wasn't losing the attrition battle. They were never in it. For every British fighter they destroyed, factories produced nearly 2 replacements. Women working night shifts at Castle Bromwich and Hawker's facilities were outproducing the entire Luftwaffe combat force. The pattern intensified as the war progressed. During the 1941 Bedka raids, Luftwaffe bombers attacking British cities faced fighter opposition that should have been severely depleted after a year of combat operations. Instead, squadron strength remained constant. When Bomber Command launched its strategic campaign against Germany in 1942, the Germans anticipated that aircraft losses over the Reich would eventually force the British to scale back operations. By 1943, Bomber Command was losing 50 bombers some nights, an unsustainable rate by traditional calculations. Yet raid sizes kept growing. Women at Avro, Handley, Page, and Short Brothers facilities were building Lancasters, Halifaxes, and Steerings faster than German defenses could destroy them. German fighter pilots over the Reich found themselves in a nightmare version of the Battle of Britain. Hauptmann Heinzke, who flew over 300 missions, wrote in his diary in March 1944 that he'd claimed 11 bomber kills that month. Yet, the formations he encountered seemed larger than ever. The psychological impact was devastating. Every mission succeeded tactically. Bombers shot down, crews killed, yet strategically nothing changed. The British kept coming. Production facilities that German pilots risked their lives to defend kept burning because the bombers overhead were being replaced faster than German industry could replace the fighters defending against them. The Normandy invasion illustrated the culmination of this industrial superiority. On D-Day, 6th of June 1944, Allied air forces flew over 14,000 sorties with fewer than 100 losses. The Luftwaffe managed under 300 sorties for the entire day. German pilots weren't cowards or incompetent. They were outnumbered because British factories had spent 4 years producing aircraft at rates that made numerical superiority inevitable. The women who'd been riveting Spitfire wings in 1941 were building Tempests and Typhoons in 1944, maintaining the production advantage that had saved Britain and now threatened Germany itself. German attrition strategy had been sound. The problem was that British factories staffed predominantly by women had made attrition mathematically impossible. You cannot win a numbers game against an opponent who builds faster than you can destroy. Victory in Europe was declared on the 8th of May 1945, and by August, with Japan's surrender, the factories that had defined Britain's war effort began shutting down assembly lines. The women who'd built over 100,000 aircraft received their redundancy notices with remarkable speed. Castle Bramage, which had employed 10,000 women at peak production, dismissed 7,000 within 3 months. Vickers, Armstrongs, Avro, Hawker, across Britain, the pattern repeated. The Ministry of Labor encouraged women to return to domestic life, and government propaganda that had spent 4 years celebrating women's industrial contributions pivoted overnight to promoting homemaking as patriotic duty. The speed of this reversal was staggering. Women who'd been praised in newsreels for their precision and dedication found themselves described in post-war publications as temporary workers who'd filled in admirably, but could now step aside for returning servicemen. Trade unions, which had reluctantly accepted women during wartime emergency, lobbied successfully for policies that prioritized male employment. The Restoration of Pre-War Practices Act essentially mandated that women surrender skilled positions to demobilized soldiers. By 1947, women's participation in aircraft manufacturing had dropped below pre-war levels. The women who revolutionized British industrial capacity simply vanished from factory floors. Official histories completed the erasure. The air ministries published accounts of wartime aircraft production focused on brilliant engineering designs, strategic ministry planning, and the dedication of Lord Beaverbrook's leadership. Women appeared, if at all, as background figures in photographs or brief mentions of workforce expansion. The detailed production records, the innovation logs, the quality control improvements, all these documents sat in archives with no accompanying narrative crediting the women who generated them. When veterans published memoirs about keeping Spitfires flying or maintaining Lancaster squadrons, they thanked ground crews and mechanics, rarely mentioning that those replacement aircraft arrived from factories staffed predominantly by women. The cultural amnesia was nearly complete. Post-war Britain wanted to return to pre-war normality, which meant women in domestic roles. Films about the war focused on combat heroism, political leadership, or male home-front contributions. The Festival of Britain in 1951 celebrated British achievement and resilience with barely a mention of female industrial workers. Textbooks taught children about Churchill's speeches and RAF pilots' courage without explaining where the aircraft came from. 2 generations grew up knowing Britain had won the war through determination and sacrifice, never learning that victory had been assembled by women with rivet guns. Yet the implications of what happened between 1940 and 1945 couldn't be entirely suppressed. Military planners across the world had watched Britain's experiment with forced detention. The Soviet Union, which had employed women in factories throughout the war, continued that practice afterward. The United States, slower to mobilize women initially, recognized that future conflicts would require total industrial mobilization regardless of gender. NATO planning documents from the 1950s quietly assumed female industrial participation in wartime scenarios. The assumptions that had governed warfare since the Industrial Revolution, that complex manufacturing required male workers, that industrial capacity was limited by available male labor, had been definitively disproven. The women themselves carried the knowledge forward quietly. They'd proven that industrial capability transcends gender, that training methods matter more than traditional apprenticeships, that innovation comes from fresh perspectives regardless of their source. Most never spoke publicly about their war work, but they raised daughters who entered workplaces in the 1960s and 70s with confidence that their mother's generation had earned. The factories may have forgotten them, The histories may have erased them, but they changed warfare forever by proving that victory belongs to whoever can build fastest.